Hello, good evening. I want to take this opportunity to welcome you back to our class. It is in this channel whereby you gain maths experience each day. Don't miss. Kindly subscribe, share, and keep watching. God bless you for your time. So today we are looking at matrices, a continuation lesson from the previous two lessons that we discussed. Our subtopic is finding the determinant and the inverse of a 2 by 2 matrix. So we will consider a 2 by 2 matrix. So I will start by saying consider the following matrix. So the matrix, we can say we have 4, we have 2, we have 1, we have 3. So let that one be our matrix that we are going to obtain its determinant and even the inverse. So we must start by understanding what 4, 3, 1, and 2 represents. So in this matrix, we will say 4, 3, 1, and 2 are elements. We call them elements of the matrix. Those are elements of the matrix. Elements of the matrix. There's something I want to show you again. Let's look at this. In the matrix, we call that one a diagonal. We have another diagonal here. So there are 2 diagonals there. In our 2 by 2 matrix, we have 2 diagonals. Namely, the one which starts from the top of our left towards the bottom of our right, we call it main diagonal. That's what we call main diagonal. The one that is starting from the bottom of our left to the top of our right, we call it other diagonal. That's what we call the other diagonal. So it's good we start by understanding that a matrix contains, a 2 by 2 matrix contains elements, it contains main diagonal, and it contains other diagonal. So once you understand that, then we can now define what we call determinant. So we will say that the determinant is the number obtained by subtracting the product of elements in the upper diagonal from the product of elements in the main diagonal. So that's what we call the determinant, a number obtained by subtracting the product of elements in the other diagonal from the product of elements in the main diagonal. So in this matrix, elements in the main diagonal are 4 and 2. Elements on the other diagonal are 1 and 3. So, considering this matrix, how do you obtain its determinant? We will say the determinant is equals to, we will take the product of 1 and 2, that is 4 times 2, then we subtract the product of 1 and 3, 1 times 3. So that one will give us, it will give us 8, then minus 3. 8 minus 3 gives us 5. So that means the determinant of this matrix is 5. So far so good. I want to believe that you have understood that a matrix must contain elements. It must contain, as long as it is a 2 by 2 matrix, it has a main diagonal and that diagonal. Then if we take the product of elements in this main diagonal, then we subtract the product of elements in this other diagonal, which we have done here, we obtain the determinant. So in this case, I want to believe that you have understood what it means by saying the determinant of a 2 by 2 matrix. So I want to show you on how we can find the matrix of the same matrix, which is 4, 1, 3, 2. So what do we need to understand? We will now say, to obtain an inverse of a 2 by 2 matrix, we follow the following steps. The first one is to obtain the determinant of the matrix. Find the determinant of the matrix. Then interchange the elements in the main diagonal. Interchange the elements in the main diagonal. Number 3. Change the signs. Change the signs of elements in the other diagonal. Then lastly, divide the matrix obtained by the determinant. Or we can say, an alternative of that, we can say multiply the matrix obtained inverse. Find the inverse of the determinant. Inverse of the determinant. Now, let's find the inverse of this matrix. Following these steps, the first step is finding the determinant, which we have already found, so we cannot repeat because we already have the inverse of our matrix. Step number 2 is interchanging the elements in the main diagonal. So the elements in the main diagonal are 4 and 2. So 2 will come and take this place of 4. 4 will take the place of digit or element 2. So we will now say our new matrix becomes 2, 4. Then on the other diagonal, the elements will remain at their respective positions, but we will change the sign. Like now we have positive 1 and positive 3. So they will become negatives. Then now we either divide by the determinant or we multiply by the inverse of the determinant. I would prefer we find the inverse of the determinant. In this case, it is 1 over 5. Then we multiply by the matrix. So now let's multiply. Remember, I've interchanged the elements in the main diagonal. We have changed the signs of the elements in the other diagonal. Now I'm doing the last bit, which is saying divide the matrix obtained by the determinant, or we multiply the matrix obtained by the inverse of the determinant. So I prefer using the inverse of the determinant, which is 1 over 5. Remember our determinant was 5. Inverse of 5 is 1 over 5. So that's what I have here. Inverse of the determinant in this case is 1 over 5. Now we multiply this inverse of the determinant by the matrix obtained by interchanging the elements in the main diagonal and changing the signs of elements in the other diagonal. Now let's multiply. 1 over 5 times 2, it gives us 2 over 5. 1 over 5 times minus 3, it gives us minus 3 over 5. 1 over 5 times minus 1, it is minus 1 over 5. 1 over 5 times 4, it is 4 over 5. So this is what we call the inverse. This is the inverse of the matrix of that matrix, which is 4, 2, 1, 3. So that's how we find the determinant and then the inverse of a 2 by 2 matrix. We can look at an example very fast. So we can say example 1. Find the inverse of the matrix. So we can say our matrix A is equals to 5, 3, 2, 1. Then we say solution. We will follow the same steps. Step number 1, finding the determinant. So our determinant will be product of the elements in the main diagonal is 5 and 1. 5 times 1. Then minus product of elements in the other diagonal, which is 2 times 3. So this will give us 5 minus 6. Therefore, our determinant is minus 1. Number 2, we will interchange the elements in the main diagonal. That's where we are adding to. So we will have 1 coming first, then 5. We maintain the rest, but we change the sign. So I've interchanged elements in the main diagonal. the other elements in the other diagonal remains the same, we only change their signs. Then now we multiply by the inverse of the determinant, which is the inverse of the determinant will be 1 over minus 1. So this is the same as minus 1, because 1 divided by minus 1 is 1, times 1 minus 3 minus 2, then 5. Minus 1 times 1 is minus 1. Minus 1 times 3 is equals to 3. Minus 1 times minus 3 is equals to 2. Minus 1 times 5 it is minus 5. So this is now the inverse. This is the inverse of this matrix. So next time we will look at singular matrix. Matrix whose determinants are 0 are the ones we call singular matrix. Thank you for listening to me today. I'm so grateful. I want to thank you so much for your support. God bless you as you continue watching, subscribing, and sharing. Bye bye.